In this problem, we're given two sets, A and B, and a function called name that has A as its domain and B as its codomain. And then there are three questions regarding this situation. Question one is, what is name of dog? So how do we find the name of dog, given that we are given the graph of this function? This set here is the graph of this function. Well, it won't hurt to recall what a graph is. If you're given a function f, from domain x to codomain y, its graph is the set of pairs x comma f of x, where the first coordinate x runs over all elements of the domain capital X. So that is exactly our given set, which means that in each pair, the first element, as we can easily see, is an element of the set capital A. And indeed, cat, dog, rat, and cow form the elements of the set capital A. And most importantly, the corresponding second elements are the images of the first coordinate. So skip is the image of cat under the function name. Likewise, Rex is the image of dog under the function name. Mikey is the image of rat under the action of our function name, and Spike is the image of cow under the action of our function f. So if we write all that down, name of dog is the second element of the only ordered pair in the graph of our function name that has dog as its first coordinate. In our case, such pair, only pair, is the pair dog Rex. And so the name of dog is Rex. Now, In the second question, we need to find the image of the function name. Again, it won't hurt to recall the definition of the concept of image. The image, which we denote Im of f, of some function f, is the set of all the elements in the domain of f, in the codomain of f. That have the form, that are images of some elements of the domain. In other words, that have the form f of x for some x. In other words, the set image of f simply is the set of simply is the set of numbers, or not necessarily numbers. This is the set of elements f of x, where x is in the domain of f. So in our case, image of the function name is name of x as x ranges over the domain of the function name, which is the set A, and this will be simply the set name of cat, name of dog, name of rat, and name of cow. Which simply is Skip, Rex, Mikey, and Spike. Now, in the third part of this question, we are asked several questions. First question is, can the function name be inverted? If yes, find the domain, codomain, and the graph of the inverse. If no, explain why not. We again recall some theory here. We know that a function f can be inverted. If and only if for every y in the codomain of f. There exists a unique x in the domain of f. such that the image of f, the image of x under the action of f is y. Now, the unique part means that our function f must be injective. One-to-one, as we used to call it. In other words, we don't allow the following situation. If this is domain, and this is the codomain, we don't allow a situation like this. Because if we were to invert this function, we wouldn't know whether the inverse function should map y to x1 or to x2. There is ambiguity. So a situation like this is not allowed. Now, the exists part means that f is surjective. Which we used to call also onto, i.e. that the image of f is all of the codomain. In other words, we don't allow a situation like this. When we have the image of the domain, a proper subset of the codomain. Then if we were to invert our function f, f wouldn't be defined at points of the codomain outside the image of f. F inverse wouldn't be defined at a point like this. So this situation is also not allowed. Now, in our case, the function satisfies both conditions. It's injective and surjective. It is, again, injective. Rather, let's first explain why it's surjective. It is surjective because its image coincides with its codomain, we found the image in the previous part, and we realized the image is the entire set B. And we can write it again here. image of name is the set consisting of skip, Rex, Mikey, Spike, and that's the entire codomain B. And likewise, the function name is injective. And clearly, that simply means that for every y and b, there exists a unique, rather, for every x1 and x2 in the set A, name of x1 being equal to name of x2 implies x1 equals x2. So we have this implication. Simply put, different animals have different names. Or rather, even better, no two animals have the same name. Therefore, the function name is invertible, and its inverse has the following. The domain of the inverse is the same as the image of the original function. That is the same as the set B, which we know again as skip, Rex, Mikey, and Spike. And the image of the function inverse to name coincides with the domain of the original function name. That simply is the set A. We know that's cat, dog, rat, and cow. So we have determined that name is invertible. We found its domain, codomain, and what's left to do is to find its graph. Well, the graph of the inverse function to name is by definition the set of pairs x comma inverse to name of x, where x belongs to the domain of the function inverse to name, which we know is simply the set B. And so this set simply is the set skip name inverse of skip Rex name inverse of Rex Mikey name inverse of Mikey and finally Spike name inverse of Spike. And computing these values, we find that this set is skip. Name inverse of skip is cat. Then Rex, name inverse of Rex is dog. And Mikey, name inverse of Mikey is rat. And finally Spike, name inverse of Spike is cow. So in fact, it's easy to see that the graph of the function name inverse is very easy to obtain from the graph of the original function name by simply reversing the coordinates in each pair. So from cat skip, for instance, we get skip cat. From dog Rex, we get Rex dog. From rat Mikey, we get Mikey rat. And finally, from cow Spike, we get Spike cow. So most importantly, again, our function name turned out to be invertible precisely because it is both injective and surjective. Again, injective means that no two animals have the same name. Situation like that is not allowed when two different animals have the same name. And surjective means that every name is owned by some animal. There's no name that is not had by some animal. So these two conditions, injective and surjective, imply that our function is bijective, and bijective functions are invertible. This problem is now over.